Hello, my name is David Arnold, and this is Team 11's design review for Project 55, Machine Learning for Automated Insect Classification. The identification of species has traditionally been a challenging endeavor, requiring extensive expertise and considerable resources. Even more so today, as the number of taxonomists has steadily declined over the years. A goal of this project is to provide a tool for researchers to efficiently and accurately identify and classify insect species. We also envision this tool being used to document and digitize museum collections from around the world, and we hope to help foster citizen science by empowering amateur naturalists to identify insects in the field. The main components of the system include a deep learning image classification model built using Google's TensorFlow, a web server, an API server to pass users uploaded images to the classification model, then return results to the client. And in addition to the website, there will also be support for both Android and iOS devices.
Hello, my name is Sadai Sarmiento. I'm going to talk about the design and architecture of our system. So here's the original diagram of our system. We have 3 data sources. This is where we pull all the different images to train the machine learning model. We also have 4 data stores. We have an internal API, and then the internal API is used by these different components in order to store information into these data stores. We also have a public API, as well as a website and a mobile application. These are the changes that we made to the original diagram. So now we removed ImageNet as it wasn't providing us with useful images for the ant classification model. We also simplified the diagram a bit by removing this training data. Now the image store is responsible for storing all the images that we used to train the model, and we're segmenting that into training as well as validation data sets. We also removed the public API component, and we changed that into an API gateway component so that we have a little extra protection over the internal API, and it also does some basic authentication and authorization as well. And the mobile apps will just interact with the public website as opposed to interacting directly with this public API. So this is what the finalized diagram looks like. Finally, these are the different components of our application, and the way we handle the development and deployment of these components is we use Docker. So for each one of these components, we have an image, and each image is then instantiated into a container, which is basically like a running process. And each running process corresponds to one of these components. Here is a sample Docker Compose configuration file. This is what we use to bring up the development environment as well as production environment. The cool thing about Docker is we can use the same file here, but with just a few slight configuration changes for both development and production environments. Well, this is the design and architectural overview. Thanks.
Hi, this is Aaron. I'm going to be going over our timeline and milestones section with you. As you can see, we've got our original timeline posted right here. In the original timeline, we kind of envisioned working on each individual portion of the system all in separate time frames. So we would start off with working on the data set for the data set for AntWeb, and then working on the machine learning model after that, and then working on a backend server, and so on and so forth. And that didn't really end up working out for us. So in our revised edition, we realized that things would work better if each of us worked on individual portions all at the same time. So in our revised edition of the timeline, it looks like all of our deadlines are pushed over here towards the end, but that's only because we reorganized how we were going to deal with the development of the system. So the 2 timelines are about the same all the way up until the end of the first semester, and then all of our deadlines are kind of pushed up to April 6th. But development is still running more or less on schedule. And then April 27th is our deadline for documentation and turning the project in, of course. And that is that. So I'm going to pass you on to our next speaker. Here we go.
My name is Francisco Bencomo. I'm presenting on the insights. The process that we used was the Agile Scrum process. You can see this is a picture from Tiger.io showing our backlog for our latest sprint, and these are just some of the tasks that we have that are in progress. We also did weekly stand-ups. Our weekly stand-ups were held through the Slack channel. It was just kind of just more of an update than anything to show where everybody was at. We would list what we were working on, if we had any blocks, and what we planned on to continue working on. The development of the project was done concurrently. We were all working on different components of the project at the same time, so there wasn't like a lot of paired development. The things that we would do differently, we would narrow the focus of our production. So instead of working so concurrently, where everybody's just kind of doing one thing at the same time, we would work on the bigger, harder, most important parts together to get those finished, and then we can move on to the things that were more simple, where working concurrently wouldn't be too much of an issue. And then we would also utilize the Scrum tools better. Tiger.io offers a lot of different stuff. One of the things that they offer is a point system that you can assign to your user stories. And as you're progressing through your sprints and your project, it gives you graphics of how you're progressing. This graph here is one of those graphs that shows you the amount of points that you've completed during the sprint. As you can see, we don't have any assigned points, so there's nothing showing on that graph.
My name is Larry Pruitt, and I'm going to go over risk management. Our risks include system integration. This is integrating the bug guide and AntWeb datasets. It is also integrating the website with the server, with the database, and with the model API. Another risk is inconsistent meeting attendance. On the right is a plot of our meeting attendance this semester. As you can see, there are only 2 meetings where we've had full group attendance. Another risk is the time required to train a model. So the maximum amount of time required to train one model is 5 days, which is a lot of time with a month and a half left. Issues include Spectrum machine availability. In the month of February, the Spectrum machine was being utilized almost every time that we got on to use it. Another issue is low accuracy of the model. We've trained 2 models on the AntWeb dataset and achieved 20% accuracy approximately each time, and this is well below our 80% goal. Dataset integration is another issue. Integrating bug guide and AntWeb datasets has proved to be especially difficult because of the way each of them are structured or not structured. Mitigating strategies include continue holding our weekly meetings. This advocates accountability. Also, we're continuing to communicate with the Spectrum machine administrator, stressing our need for GPU utilization during the last month and a half of this project. Lastly, we are dedicating more time to the project. Contingency plans, we are focusing on integrating all the parts of our project before continuing to build on the project. We want to get something working. Lastly, we are training on just the AntWeb dataset, while the goal was to train on both AntWeb and bug guide dataset.